Welcome back folks, this is Shadul Gawande from Ace Knowledge, and in this video we are going to perform the third and the last most page replacement with the help of optimal page replacement algorithm. So here again we have the same thing, same page sequence and frame size of 3. So what optimal page replacement algorithm states that replace the number which you will not be needed in future. That means, let's say a particular number we want, let's say if a particular number is there which we need in subsequent page sequences, then do not replace that number. But if there is a number which we do not need in further page sequences, then simply replace that particular number. Well, this is quite complicated to understand, so let's make it easier, or let's understand it by solving the particular sums. Okay, so let's start. So we have the first number which is 0. So here we will have a page fault because 0 is not present in our particular memory. So we write here as 0 and then dash. The next number we have is 1. Again we will have a page fault. So 0, 1, dash. Next we have 4. 4 is also not present. So 0, 1 and 4. Now we have number 2. Okay, so now what optimal page replacement algorithm says that replace the number which you will not be required in further page sequences, or at least for further 3 to 4 subsequent numbers, that is 2026 or 202. Mostly will take 4 subsequent numbers. So do we require 0 in further 4 subsequent numbers? Yes, there is a 0. So we will not replace the number 0. Then do we require 1? Yes, but not in at least not in the 4 subsequent numbers, but at least ahead or in the further subsequent numbers we will require 1. So let's not replace 1. Number 4. Number 4, do we require anywhere over here? No. So let's replace number 4. You can check as of now for at least 1, 2, 3, 4 subsequent numbers or till the end. But mostly I will prefer to check in both the manner, 4 subsequent numbers or till the end. Okay, so 4 is not required. 4 we will not require 4 anywhere in future. So let's replace the number 4. So 0, 1 and number 2. Okay, we have replaced number 4 with 2. Next is 0. So here we were having page fault. Now here we are having page hit because 0 is already present. So 0, 1, 2. Next we have 2. Again we have a page hit 0, 1, 2 because 2 is already present, so no page fault. Number 6, we are having a page fault over here. So now check whether we will be requiring any of these numbers in our future. So 1 we will require, so for next 4 subsequent numbers, so 1, 2, 3, 4. So 1 we will require, so 2 we will require, but number 0, I guess number 0 we don't require in future. So let's replace number 0. So 6, 1, 2. Okay. Next is number 5. So again a page fault. So number 5 is not present. So for 1 and 2 we will require. So no replacement of 1 and 2. Number 6 also we will require, but it's quite far away from our current position. So let's replace number 6 as of now because 1 and 2 we will require. So we will have here 5, 1, 2. 1, so no replace, no page fault. So 5, 1, 2 we will keep the same because the number is present. Number 2 again no page fault, we have a page hit over here. 5, 1, 2. Next we have number 3. So page fault because 3 is not present. So now which one to replace? So for next subsequent 4 to 5 numbers, 1, 2, 3, 4, 5. 1 we will require 1, 2 we will require 2, number 5 we will not require in future, so replace 5. So 3, 1, 2, replace 5 with the next page sequence which is 3. Next 2, so page hit 3, 1, 2 because 2 is present, then 1 again we have 1, so we have 3, 1, 2, we have a page hit, again 2, so page hit 3, 1, 2 because these numbers are present in our memory. Number 6, page fault because 6 is not present. So now which one to replace? So check for the numbers. So 3 we will require 3, 1 we will require 1, 2 we will require 2. So now here it is a case where all the 3 numbers we will require. Okay, we will require further all the three numbers. But now look these three numbers we will require, right? But which is the number which we will require at a very early stage? That means after 6, the immediate number among these three numbers, which is the number which we will be requiring, the very first one. So the number is 2. So we will not replace 2. The number is 1. Next is number 1. So we will keep the number 1 also. But number 3 is very far away from our current position. So we can replace number 3 because it is too far, right? So we will replace number 3. So we will have 6, 1, 2. 1 and 2 we have not replaced because immediately we will be requiring number 1 and 2. So that is the reason we have not replaced 1 and 2. But 3 is very far from our current position. So we can replace our number 3. So that's how you have to check for the replacement of numbers, right? So now number 2. So no page fault because number 2 is there present. So we have 6, 1, 2 where we have paged it. Number 1 it is still there because we have not replaced because we were requiring these two numbers. So 6, 1, 2 we have a page it. Now number 3, so page fault because number 3 is not present. So which number to replace? 6 we need it immediately. Even 2 we need. So number 1 we don't need. So replace number 1. So 6, 3, 2. Now number 6, so page hit because 6 is present. And number 2 again which is present. So 6, 3, 2 page hit will occur. So let's count the total number of page faults. 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 page faults we have got, and that's how optimal page replacement works. So we'll write your total number of page faults is number 9. So that's it from this video. Thank you so much for watching and don't forget to subscribe.